Hi, my name is Jaewon Cho from KAIST, and I'll be presenting Dealing with Missing Modalities in the Visual Question Answer Difference Prediction task through knowledge distillation. In this work, we tackle the Visual Question Answer Difference Prediction task, which we call VQD from short from now on. In this task, we are given an image, a question, and we have to predict why the answers might be different. Due to the concurrent VQA and VQD challenges running, the answers are not present at test time. So in a basic VQD model where we have the image, question, and answer to predict the difference, in the realistic VQD model, we have to use the image and question and predict an intermediary answer and then try to find the difference. To overcome this, we propose a knowledge distillation scheme using individual modality teachers and a big teacher model to train a student model which only has the image and question available at both test and train time. In order to distill knowledge well, we first create a big teacher model that uses all three present modalities to outperform previous baselines. In this big teacher model, we have two attentions, where the question is attended by the answers once, and then the image is attended by the question and the answers, and all of these features are multiplied and passed through a classifier in order to answer the answer difference. Then we use not just a big teacher model, but individual modality teachers, such as the answer teacher, image teacher, and the question teacher, and distill not just the predictions, but the intermediary features from either the MLP or the attended features into the student model using an L2 loss. For our experiments, we show our experimental findings on the VisWiz VQD validation set. And first, we show that our big teacher model outperforms all previous baselines by a small margin. Then, in order to test to see which of the individual modalities are helpful to train the student model, we distill the individual modality teachers. We find that some of the teachers are not actually helpful individually or at all, and we can see some things like the question teacher is actually detrimental to the performance for some categories such as low quality image, as the question teacher is not able to see any of the actual images. Then we use different combinations of the big teacher plus image, question, or a combination of these individual modalities with the intermediary features as well, and find that big teacher plus the image teacher and the question teacher with their intermediary features actually perform the best. Additionally, we show our results on the VQA V2 VQD dataset, and we can also see that our model performs the best among all of the baselines. We also show our qualitative results, and the threshold is, as a sigmoid is applied, the threshold is 0.5 for true and false. We see that even though the baseline may be wrong, that if the teachers are correct, the teachers can guide the baseline into having the right answer. However, there are also failure cases where even though the baseline was correct, when the teachers are wrong, they ultimately distill the wrong answer to the teacher, and the student will learn the wrong answer. In conclusion, we first propose a big teacher model that makes use of all present modalities and shows a favorable performance against current baselines. And in order to tackle the issue of answers not being present at test time, we use a knowledge distillation scheme to teach the student model using individual modality teachers and the big teacher. Thank you.